for our PI controller with a motorized pendulum at this time. We're trying to get a desired degree of 20 degrees. The motor is trying to reach its steady state position. As you can see, for our 20 degree angle, 90 degrees would be 0, 100 degrees would be 10 degrees, and 110 would be our 20 degree desired angle. For the motor to reach a steady state position, it's around 7.70 to 7.74 volts, which it has reached that steady state position at this time. We're going to also demonstrate when force is given upon the pendulum, the motor, you're going to see a voltage gain, and the motor is going to try to go ahead and accelerate the propeller so it can go ahead and reach that steady state position at this time. You can see force is being given upon the pendulum, the motor at this time. That voltage did increase to 7.87, 89, 90 volts. And when the pendulum is released, you're going to see how that voltage tries to go ahead and reach that steady state voltage again of 7.74, 7.70 volts. Also, when force is given to the pendulum for the forward force, you're going to see how the voltage drops and the propeller decelerates to be able to get back to that steady state position, which is the 70 degrees and that 7.70, around 7.70 volts. The big decrease in the voltage, now it's around 7.30 less volts at this time, and you can also hear as the propeller decelerates while the force is given upon it to be able to reach that steady state position at this time. When it is released, it's going to go back to that steady state position while it oscillates to be able to reach it again around 7.70 to 7.74 volts. As you can see, this is our PI controller. It has 5 op-amps. The first one is a summer, the second would be our proportional part of the controller, the third would be the integral, the fourth is another summer, and the fifth is an inverter. An inverter is used due to the voltage coming out of the fourth op-amp is a negative voltage to be able to feed the motor through the transistor. At this time, we're going to go ahead and demonstrate also the voltages at each op-amp. At op-amp 1, we have a voltage of negative 5.59, 5.60 volts. At op-amp 2, we have a voltage of 5.26, 5.27 volts. At op-amp 3, we have a voltage of 5.56 volts. At op-amp 4, we have a voltage of negative 10.75 volts, and at op-amp 5, which is our inverter due to that negative voltage coming out of op-amp 4, is that steady state voltage that's needed to get the motor to the 20 degrees of 7.70, 7.72 degrees, 72 volts, I apologize. And we also have a variable resistor. At op-amp 5, that variable resistors is what gives us the freedom to be able to change the degree of steady state that we want for the motor. So if we want 20 degrees, we would increase the gain on the variable resistor to be able to get that gain. And that concludes our PI controller demonstration with the motorized pendulum.